Greetings, ladies and gentlemen, and welcome to the Breaking Down the Barriers to Connect Factories conference call. My name is Kimberly, and I will be your operator for today. At this time, all participants are in a listen-only mode. Later, we will conduct a question-and-answer session. If at any time you require operator assistance, please key *0 and an operator will be happy to assist you. As a reminder, this conference is being recorded. I would now like to turn the call over to your host for today, Paul Korostowski. Please proceed.
Thank you, Kimberly. Welcome to today's webinar about one of the most significant challenges facing today's manufacturers, the need to connect autonomous information silos. I'm your moderator, Paul Korostowski, and joining me for today's discussion are Steve Jennis of ADLINK and Kevin Davenport from Intel. Steve is Corporate Vice President and Head of Global Marketing for ADLINK Technology. He spent a number of years with Texas Instruments before leaving to help start up PrismTech, a specialist in software products for high-performance distributed systems. PrismTech was then acquired by ADLINK primarily to accelerate the company's edge computing strategy. ADLINK is a global leader in embedded and industrial computing platforms. Kevin is the Global Director of Industrial Solutions at Intel. He brings over 20 years of experience from corporations such as Cisco, Pacific Gas and Electric, Applied Materials, Omron Electronics, and Beckhoff Automation. During his career, Kevin has driven adoption of a diverse set of manufacturing and industrial solutions, ranging from end-to-end IoT systems to tightly integrated discrete machine and process control systems. Thank you both for being here today.
You're very welcome. Thanks, Paul.
Yep, good to be here.
Great. So let's start with a discussion about where we are today. Manufacturers looking to build connected factories first have to deal with legacy systems. This can be quite a problem for some because 90% of factory assets are not connected to a network. This legacy also is reflected in corporate hierarchies, where the IT, information technology, operations, and communication and networking teams typically have had limited interactions. With that backdrop in mind, Steve, this question first goes to you. Why and how does the move to connected factories make IT, OT, CT collaboration more important?
Yeah, thanks, Paul. I think the answer to that starts with the realization of where the new business cases for the industrial IoT actually occur, and they occur in a cross-domain fashion. You know, within IT, OT, and CT, or communications technology, new technologies have been deployed for many, many years, technology upgrades and so on. But what's different about this disruptive new technology is the cross-boundary aspects of the industrial IoT. So you have technical, cultural, and vendor ecosystem requirements to address those cross-boundary business cases. Now, they can be targeted at operational excellence. They can be targeted at supporting new business models. They can even be targeted at environmental factors like eliminating waste or reducing energy cost or suppressing pollution and so on. So there's lots of new business cases that, you know, can occur with this cross-boundary collaboration and interoperability. So we have, you know, CIOs who've traditionally been focused on the data center or the cloud, having to learn about operational technology data sources down on the shop floor. We have the OT people thinking about cloud platforms, and we have the network people, you know, the ATs and Ts and Verizons and Ciscos thinking about edge computing and in their terminology, virtual CPE or customer premises equipment. So just throwing technology at the problem won't work. Top-down thinking, cross-domain thinking, cross-organizational thinking forces the collaboration to make these things happen. So where does that occur? Well, it's commonly called edge computing because it's where these different communities meet. And as I said, these communities are not just identified or characterized by technology, but they're also characterized by the operational boundaries within a corporation, maybe by the ecosystem of vendors that they work with. In the IT world, you have the Oracles and IBMs and SAPs. In the OT world, it might be Schneider, it might be ABB, it might be Siemens. And in of course, the networking world, you have the Ciscos and AT&Ts, as I mentioned. So there's a number of boundaries, cultural, vendor, and technology that need to come together to create these end-to-end solutions.
Very good. So, Kevin, what are your thoughts on trying to get these groups to try to work together more easily and effectively?
You know, that's a good question. You know, sometimes getting IT and OT business units and entities together is almost as tough as bringing the rival between the Cavaliers and Warriors or Hatfield and Cloys together. You know, it can be pretty difficult. But I understand there's a couple reasons for that. One is there's reasons that the culture between IT and OT are different. So, for example, IT is pretty much defined by mostly constant change and innovation. And although OT has innovation, obviously, they're more risk and change adverse. That's why it's not unusual to see industrial automation systems in service for decades at a time with little or no change. You know, it's very CapEx intensive, and downtime, production costs, mean time between failure, operational efficiencies, they all come into play. So whereas there's a cultural change, a cultural difference in terms of technology refresh, that's one of the main differences. The other is closely similar, but it's around the monetization question. So again, industrial technology investments are highly ROI driven. This is especially true in industries where margins are typically thin in smaller organizations where cash may be in short supply. So unless decision makers can see, or OT decision makers can see a clear path to monetizations around new technologies, typically within 12 months or less, these investments are generally non-starters for the OT organization. So being able to answer how these use cases that Steve kind of alluded to, how technology, not just for technology's sake, but technology for value's sake, can add values to some of these barriers is extremely key. So that's why most of our customers and vendors now talk around value and use cases and how technology can bring relevance to that, as opposed to technology for technology's sake. And lastly, there's the security question, right? So it's not just around IP and having access to intellectual property, but cybersecurity systems really have a huge effect or additive effect when you talk about OT systems, from, you know, production times and downtime to environmental safety and hazards. So those things are key. So traditionally is security by obscurity on the plant floor. So now that we're starting to connect these systems together, it's extremely important to answer that security question.
Okay, excellent. So we've covered a number of different types of topics here. Steve, do you want to dive down into items that you think might be the 1, 2, 3 major pain points that companies are facing as they try to integrate these different groups and build smarter, more connected factories?
Yeah, it's, you know, focusing on pain points can be somewhat negative, but it's also the opportunity for vendors to help solve customers' problems. So we can look at this as in a positive sense as well. The starting position is quite complex. You know, as Kevin mentioned, you know, you have data silos, you have vendor equipment or vendor ecosystems already in place, which might be closed or using proprietary protocols. You have, you know, the IT, OT, and CT people coming from their own comfort zones and their own terminology. So to force all this together, you have to focus on the new value add that you're bringing to the business. This isn't going to happen organically. Well, it might happen organically over a decade or two, but if we're going to make progress in the short term, we have to look at these new business cases and what drives these organizations together to overcome these pain points and deliver what I think is a very key statement, end-to-end solutions, because the drivers in terms of the business case, whether it's operational excellence, eliminating downtime, maximizing product quality, whether it's supporting new business models like data services post-sale, or whether it's environmental concerns, the business cases are very clear and very accessible if you can overcome some of these technical and cultural and legacy boundaries. And that's where we have to focus as a vendor in providing these solutions to help customers overcome these areas. So, just in a summary, I'd say that the pain points are well understood. Just getting data off of a legacy machine tool can be quite challenging, particularly if it's 10 years old. But, solutions are coming to market. I'll mention a few later on that can help with this. And once you free up that data and make it available to flow across these corporate boundaries, then all sorts of magic can happen in terms of new value add, new applications, and new services. Okay?
Yeah, great. There's a lot of information there. So, Kevin, so technically, we have a lot of different types of devices that are being connected. So what would you say from a technical standpoint are a few of the areas where some work has needed to be done recently to try to connect these systems and get more integrated types of factory solutions?
Yeah, so the technical gaps are not trivial. So when we're trying to address getting to, or that path to value around IoT, we always talk about the path to value or these use cases, but being able to make or use technology to get to that value in a simple way is not easy. And some of those technical challenges stem around a few buckets. One is around security. Again, as I mentioned before, security by obscurity or by a wall silo approach just doesn't work. So you have to embed not only a perimeter strategy, but an on-device strategy when you're talking about security. So there has to be a few provisions that you have to make to clearly get specifically the OT buying center comfortable with your solution. You have to address the security concern. The other is around connectivity. So to address the complexity of being able to manage and access data from a diverse set of proprietary systems, whether it be machines, sensors, motors, you have to evolve some of the closed proprietary standards that are in play and merge them with some of the IT technologies in a way that still address the uptime and the availability and the determinism that you need on the OT side of the house, but be able to address those concerns with open-based standard technology is the key. Unlocking that data is extremely important. And then the other question is around technology gap is around scalability. As we talk about the billions of devices on the wire, I mean, you just can't scale and connect those number of devices without a connectivity strategy that includes wireless. So being able to deploy a wireless strategy as well as a very reliable connected wired strategy is important. So those are kind of the buckets, security, connectivity, and then data manageability.
Well, that's a great overview of all the different technical issues there. In this market, there's a lot of talk about vendor ecosystems. So why are ecosystems important? And Steve, what are some of the pieces that have been missing from these ecosystems that made it maybe a little bit more difficult for folks to try to realize some of these potential benefits?
Well, I think it's quite understandable that vendors and their ecosystem partners have focused onto their core competencies. So you get different groups of vendors addressing different parts of the corporate computing problem. You know, typically in the IT department, you'll have people focused on ERP systems or HR systems or payroll systems. They might be very familiar with IBM and Oracle and SAP. In the OT world, you have people on the shop floor. Traditionally, we might have called them islands of automation, SCADA systems, DCS systems, computer integrated manufacturing systems. Technology's been deployed for a long time to do real-time control on the shop floor. And then in the CT world, of course, you know, the cloud services delivered over Wi-Fi or cellular come with their whole own ecosystem of vendors, and the carriers, the Verizons and AT&Ts of this world are pushing to the edge to add value and more support for device data communications at the edge of their systems. They call it multi-access edge computing, or MEC, in that world. So you've got the vendors traditionally focusing on their areas of core competency, whether it's OT, IT, and CT. The new business cases emerging that take us down the road towards the digital enterprise cross these boundaries, and so all these vendors are being forced to think beyond their comfort zone. They're being forced to think about, if I'm an OT guy, how do I exploit cloud computing? If I'm a network guy, how do I support on-premises equipment? If I'm an IT guy, I have to learn about how my company, you know, makes money as well as spends money, you know, understand the shop floor environment. So all of the vendors are headed towards the same goal. It's a bit of the Wild West of computing now at the edge, you know, because everybody sees the edge as their boundary with other systems. So the IT people see the southbound boundary to the OT environment. The OT people see the northbound boundary to the IT environment, and the network people see their boundary to the enterprise as the edge of their system. So edge computing is a big hot topic right now because that's where the vendor ecosystems touch and have to be integrated. And of course, the opportunity for us all is to create those solutions that make that integration as painless and as seamless as possible, whilst exploiting legacy environments and whilst taking advantage of new technologies like cloud computing, being aware, as Kevin said, of end-to-end security, and most of all, this is driven by the end-to-end business opportunity, as I said before, whether it's operational excellence or new business models or other drivers. So the ecosystems are moving, but everyone is having to deal with a sort of learning curve towards the digital enterprise. Okay?
That sounds great. A lot of great information there. So the issue, we keep talking IT, OT, CT. Corporate culture, what sort of barriers does that present to some of these executives who are trying to push for connected factories? Kevin, would you like to address that issue?
Yeah. You know, Steve alluded to end-to-end connectivity, end-to-end architectures from a technology lens or perspective. But, you know, the benefits of IoT or Industrial 4.0 also has to be an end-to-end play across the organization or across the manufacturing value chain. It's the same concept. So traditionally, these barriers exist because, if we're being very frank, the various business units throughout the manufacturing chain, whether it's the supply chain organization, the production organization, R&D organization, or even the sales organization that's responsible for customer acquisition and retention, those tend to be siloed type organizations. You know, for example, the maturity in the budgets, each have a P&L. That P&L is funded and you're measured in a siloed fashion, if you will. And sometimes the maturity of the investments make the maturity of the technologies a bit skewed within those various business units. So when you're taking a look at IoT or Industrial 4.0, we have to take a look at how it affects the entire integrated stitched value chain instead of siloed sections. So one of the use cases that are business cases or best known methods that we've been working with some of the successful customers is around this advisory board, this IT, OT, CT advisory board, where you have members of each organization, technical members and business members, not only address and identify technology that can benefit the value chain, but it's also funded. So it's just not an advisory or consultative function, but they're actually budgeting around the whole value chain. So for example, you don't have just wireless technology or a connectivity strategy for supply chain or production. You're looking at it how the connectivity play can drive value across the whole value chain. So pretty long answer, but being able to look holistically at the entire value chain instead of siloed within the business units is a best-known method that we're seeing.
Great, so that's a lot of good information there. Steve, you touched upon it a little bit. Edge computing, what sort of role is it playing, and how can manufacturers and companies use it to overcome some of these traditional hurdles in their systems?
Well, I think edge computing is a new term to many people. My definition of it is computing at the edge of a network. So that can be at the edge of an OT network, it can be at the edge of a corporate IT network, it can even be at the edge of a telecom carrier network. So it's, as we said before, it's the boundary where these different worlds meet. And, so edge computing is taking on the role of this integration challenge to allow data to move seamlessly across the organization to allow new value-creating opportunities. Now, we've talked a lot about the barriers and the legacy problems, but let's talk for a minute about what's happening in terms of solving these problems. And I think, the vendor community is making good strides towards solving these problems, but more importantly, the end-user community is beginning to realize that this is not just another technology cycle, this is not just another technology upgrade, this is a discontinuity in their business model, and if they don't become more data-driven, if they don't move towards becoming a digital enterprise, their whole existence is threatened from a competitive standpoint. Whether you have to strive for operational excellence in terms of things like predictive maintenance, or you're striving for providing better customer support in post-sale data services, or whether you're trying to be more environmentally friendly, the business cases are clear, and the end-user community is demanding solutions today. We've seen this evolution over the last 3 years quite quickly, from people considering this as sort of an interesting technological sandpit to play around, to evolving to business-changing strategic emphasis on these end-to-end technologies. So the end customers are ramping up, the vendors are moving forward, but from a vendor position, and as a vendor myself, what we have to do is to provide the enabling technologies and the ecosystems around those to solve these problems for end users, and not basically give them 90% of the solution with a huge hole before they can derive value from it. So the last mile is important, the first mile is important, but edge computing solutions that support data ingestion, data normalization, data connectivity, have inbuilt connectivity to cloud services like Amazon, Google, Bluemix from IBM, even GE Predix. These sort of built-in plug-and-play capabilities, multi-protocol support, compute at the edge with killer applications like predictive analytics. If we can bundle these things together and make them easy to deploy, easy to configure, easier to connect, then the end users are very, very motivated to get the business cases running and deploy this technology. So that's our role, make it easier to deploy and overcome these barriers to new business value. Okay?
That sounds great, yeah. So now drilling down from sort of the hypothetical into the practical and things that we can start to implement. So how are Intel and ADLINK working together to enable manufacturers to connect heterogeneous environments? Kevin, do you want to start with that?
Yeah, I can start. And Steve gave me a good lead into this. So Intel is, we still look at ourselves as providing the innovative ingredients, if you will, to provide partners, strategic partners like ADLINK with the building blocks to plug in these solutions, make them application ready. But customers don't want a system where they have to do a lot of work. So they want plug and play ability. So partnering with ADLINK, who's a leader in gateway technology and cloud and fog computing solutions, provides us a very nice platform to provide them with, again, those ingredients around security, compute, connectivity, manageability, interoperability, a very strong ecosystem where they can leverage and partner with other vendors for ingredients and value differentiation. So the platform that we created is something that we're targeting for brownfield and greenfield implementation. So most of our customers, and probably most of the callers or attendees on the call, they have a lot of brownfield implementations where they have machines and they have systems that aren't even connected. So how do you connect those machines to take advantage of some of these value opportunities with IoT? You can't just rip and replace everything out. So where we're partnering with ADLINK is to create a gateway or box, if you will. You can call it whatever you like, a black box, but something that connects to the back of your machine that makes it industrial IoT ready, where we can, as Steve mentioned before, pull data out of the box, ingest it into a fog architecture where we can do analytics at the edge, bring it to the cloud for further analysis and capabilities to really drive smart and intelligent business decisions throughout that value chain we spoke about earlier. So it's key. And if you have a greenfield opportunity, it's the same. It's foundational to, again, that edge-to-edge play where we're building solutions both wired and wireless to be able to connect, provide compute and analytic capabilities, and just as important, as we mentioned before, provide the security infrastructure that gives the comfort and the assurance to our customers that they can plug this solution in and begin gaining value from some of these IoT value propositions and use cases.
That's an excellent overview. Steve, what do you think is new or different about what Intel and ADLINK have been doing with their approach?
Well, I think we have to understand that providing these new solutions is not only a challenge for the users in terms of organizational boundaries or existing silos of data. It's also a challenge for the vendor community in terms of working together. I like to reference a sort of jigsaw, really. You know, you've got to get to the picture from all the pieces, and to present the picture to the end customer in terms of these new value-adding opportunities, new business advantages that they can reap, you have to show them not just the pieces of the jigsaw puzzle, you have to show them the picture. And that's where Intel and ADLINK and other players play a vital part in the supply chain in terms of aggregating the technologies together into what we're calling market-ready solutions. Market-ready solutions are ready for the systems integrator or the end user to deploy and configure and start creating value quite quickly in a matter of days or weeks, you know, rather than months of custom development. You know, to get this package of technologies right, fit for purpose, if you like, you have to look at it not just bottom up in terms of the latest chipset or the latest software application, you know, or the latest gateway design. You have to look at it from bottom down, from top down as well, in terms of what the customer is trying to do, what their legacy environment is, who their partners are in terms of systems integrators, and how they can apply this new technology to best effect. So Intel and ADLINK have been working very closely together on strategies for aggregating technologies into packages that address these problems of data ingestion, data normalization, data connectivity, and supporting new applications, whether those applications are deployed on the device or in an edge gateway or in a fog node or up in the cloud or a corporate data center. So we have to wrestle with all this technology variety and create solutions from it that customers are very happy with. And you know, it's a bit like, if you're old enough, you'll remember the days of the personal computer when we went from you know, hobbyist kits to the IBM PC. I know it's very long ago now, but that's what we're trying to do here. We're trying to go from technology kits to business-ready solutions, and that's where ADLINK and Intel are working very closely together to get that right.
Sounds intriguing. Kevin, what do you think are a few of the potential business benefits that companies can realize by adopting some of the Intel ADLINK solutions?
Yeah, well, I don't know about you, but you know, I get a package at the door almost every day, and what I mean by that is that the sheer acceleration, velocity, and volume by which businesses have to operate are orders of magnitudes, at a scale of order of magnitude in terms of the acceleration and how we expect products to not only be delivered, produced, but how we want our customers to our companies to interact with us. So all that to say is this: if we're able to provide an end-to-end architecture that unlocks data from edge to cloud throughout your whole manufacturing value system, whether it's from supply chain, production, even back to R&D in terms of how we are able to take insights from communities, whether it's from the ecosystem or customers, and run that back to R&D so that we can produce better, design better, deliver better. All the value cases and or use cases that Steve mentioned before that we're trying to solve, we have to bring value to from a technology standpoint. So whether it's supply chain agility and driving acceleration through the supply chain to make sure that you can produce your product just in time, literally just in time, is key. Whether you're using the technology to better predict downtime and use analytics to, more importantly, prevent downtime is key. Whether you're able to drive R&D and customer collaboration where you're getting information from those production and machine systems to drive how you can better engineer, manufacture, design products is key. Even taking the intelligence that you garner from your customers, through, whether it's from warranty intelligence or just sheer being able to open your enterprise portal to get ideas from your customers and driving that through your value chain. All these various use cases have to be enabled by the end-to-end architecture and the plug-and-play ability around data normalization, ingestion, analytics that Steve so eloquently talked about before. So all those things have to come together and make sense to drive true business value. That's the key that I always come back to. We have to solve issues with technology. We just don't have to throw technology for technology's sake. And that's the value that ADLINK and Intel is bringing to the market.
That's an excellent overview. Steve, do you have any actual user case studies that you could provide where some potential edge computing benefits have been put into practice?
Yeah, so let's get real pragmatic here. We've talked quite a lot about the users, the end user community getting it. You know, they understand this isn't just another technology cycle, it isn't just a database upgrade or a new chipset. They understand this is an existential threat to their business. It's an opportunity, but it's also a threat. moving towards the digital enterprise is a board-level directive. But let's get real pragmatic. How do the people on the shop floor view all this digital enterprise talk and CT, OT, IT integration, and do they view this as an opportunity or a threat? Well, our job is to minimize the threat and maximize the opportunity, if you like. So what we do is we focus in on very pragmatic, tactical solutions that help people start or continue the journey towards a data-centric organization. That might start down at just getting data off a legacy machine. What we call, some people call data acquisition, what we call connecting the unconnected. And as we started the call talking about 90% of brownfield equipment not being connected to a network, that clearly limits the value of the data that those machines are creating. Some people say, what's the value of connectivity? And I just ask them how long it takes. How long does it take them to notice that their cell phone has lost connection? And most people say, well, in a couple of minutes at most. And I say, well, you're unconnected when you don't have that signal. And they say, oh, wow, now I know the value of connectivity because my cell phone without connection is 1/10 of the value to me as with connectivity. So connecting the unconnected, we have specific products addressing that, multi-protocol, data ingestion, data normalization, and then making that data available in IT-compatible formats to be shared with the rest of the enterprise or to cloud services or over a telecom network. That's a very simple use case at the very edge, just connecting the edge device to an edge gateway for data ingestion and normalization. Then you go to the next level and you say, well, now I've got the data off those legacy machines, I can start to optimize my production across a unit, whether it's a production line or whether it's a particular part of the plant. How do I now leverage that data to add new value? Is it in operational excellence? Is it providing information back to the supplier of that equipment so that they can provide me with better on-site support or less inventory overhead? How can I reap value from that data? And predictive analytics is one area, or any analytics, to be honest, whether you're doing diagnostic analytics, descriptive analytics, predictive analytics, it's all steps on a path towards more value extraction from the data. Analytics at the edge is desirable and in some cases necessary. I mean, just imagine a ship and you want to do analytics on the turbine engines running the ship. You can't rely on a low-cost internet connection to the cloud to process that data. You have to do the analytics on board, and then when maybe you get back into port at the next port of call, you can connect into an affordable broadband network and stream that data up to the cloud. So you can get aggregation of performance across thousands of engines working around the globe on a relatively real-time basis, and you can get a real-time basis actually on the vessel itself, where you're doing predictive maintenance on the engines. What spare parts will you need to replace at the next port of call? What engineering expertise will you need available in that port? And of course that helps the vendor as well in terms of resource allocation and inventory optimization. So once you get the data off the asset, whether that asset is a ship or a machine tool or a production line or a new OT, IoT thing, it's a new thing producing data. Once you get that data into the system, you can add value at the edge, on the gateway, in a fog node, which is delivering cloud-like services on premises, and the telecom people talk about that as a virtual CPE, customer premises equipment at the edge of their networks. And then you can add new value up in the cloud as well. As I said, aggregating big data across many assets that may be spread around the globe. You can get a longer-term trend analysis on a production line and of course that helps the vendor, the production line, improve their designs, improve their the ruggedness and robustness of their equipment. So we take it from getting the data off the data source, making it available for processing at the edge or further up the hierarchy, and taking advantage of all technologies, whether it's cloud to sensor, and that's the definition of fog computing, is a continuum of computing capability from the cloud service down to the sensor, where you can add value where it makes sense. Kevin mentioned security many times. Security is helped by not having to share all the data everywhere. You can keep it at the edge, you can keep it in a boundary condition, you can have firewalls, you can do a lot with the data locally, extract new value locally without running the risk of sharing that data over the internet. And that's another downside of purely a cloud approach, is compartmentalization of data really helps with security strategies. So, you have to think about it, as I said at the start of the call, in terms of the tactical use cases that customers need to solve in the short term on a longer term strategic journey towards a data-centric enterprise. And we need to help them on that road. So we start by helping them get their data off their equipment and then to process it locally with applications and then connect to the cloud, whether that's Amazon or Microsoft or GE or whoever. So we get the best of all worlds in terms of compute to support value add across the enterprise. Okay?
Yeah, that's a great summary there. We've talked a lot about the current potential barriers as well as some potential solutions. Kevin, how do you see this area evolving in the next year or two, and what sort of changes should folks start to prepare themselves for?
Yeah, so I think we all should prepare ourselves for, as I mentioned before, the sheer speed and volume of design cycles, production cycles, delivery cycles. It's going to be unprecedented. In order to keep our companies viable and serve our customers in a way that creates not only brand stickiness but brand loyalty, we're going to have to leverage the systems that we're producing, because as we unlock this data, the sheer volumes of data and the sheer speed of the data is going to allow us to create business decisions at a rapid pace. So what I see evolving within the next 12 months is the plan is already in place. We're able to, companies now are planning how to use this digitization to drive efficiencies across the value chains that we talked about. Steve is very good at describing how we can use technology and apply to these types of use cases. But the Internet of Things and industrial IoT has been around for about 5 or 7 years. And so we're seeing definite plans around how to leverage the technologies to drive those use cases. So in the 12 months, the planning is going on, but we're actually seeing implementations on a broad scale, not only from some of the large multi-conglomerate manufacturers, but even from the small vendors as well in the ecosystem that he spoke about before. So the planning stages, if companies, or whether you're an ODM or end user or system integrator, we're pretty familiar around the technology. Now it's around how to plan it and stitch it together to make sure that we implement these value buckets. The other thing that's driving this will be the autonomous nature in terms of how we deliver solutions and produce. And the other trend will be around, again, to create that brand stickiness and that brand loyalty, customization. So customization will drive that brand loyalty and stickiness in our operations and how we deliver, and data will be how we are able to use the data to create that type of business model is the key.
Okay, well, that's been great. We have some time left. I think at this, we're interested in your input as well, the folks that are in the audience. I'm going to hand it back to Kimberly for a second, who's going to mention or go review how you could submit a question if you have one for our panelists. Kimberly?
Ladies and gentlemen, if you would like to ask a question, please press *1. Once again, if you would like to ask a question, please press *1.
Okay, so following up on some of these points, Steve, you mentioned some customers are basically been putting in some different solutions. What sort of time frame do you think that it takes, and do you have any guidelines or general rules of thumb for implementation, how long that would take?
Yeah, I think, customers are driven by time to value, and that helps their ROI, their return on investment, justification for investment. So time is critical. And, it's easy to say it depends on the legacy situation, but we're doing our very best to make the deployment and value of our gateways, particularly smart gateways, very fast indeed. So it's a packaged product, it's robust, it's designed for industrial environments, but more importantly, the software stack that it supports is pre-configured to allow data ingestion from a wide range of protocols that are commonly used in the operational technology environment, protocols like Modbus, like OCP, and so on. So you have this sort of plug-and-play capability, and we use a normalized data model in the gateway to make more sense of that data from different sources and make it available for sharing either peer-to-peer or northbound up to other systems in the hierarchy. So, using that software and hardware combination, you can get to value in literally hours or days at most by connecting the unconnected, using these smart gateways. And I say smart gateway a little bit deliberately because, the first generation of gateways were just sort of fairly dumb sort of protocol converter gateways, but now we're looking at not only supporting data ingestion, but normalization and compute on the gateway itself. So that's another edge computing device. And we can deploy some pretty smart applications on the gateway, sort of scoring engines for analytics and so on, and even application development suites to allow customers to add more value at the edge. So these solutions are becoming more and more packaged. Of course, some applications like predictive analytics using machine learning might take weeks or months to optimize the algorithm, and so that learning process can take much longer. But that's really a data science issue, rather than a deployment technology issue. So, as I said, the goal here is to get people up and running in hours, days, a week at most, with adding new value in terms of data ingestion, data normalization, and then, of course, the sky's the limit in terms of what value you can derive from that data by adding new applications and so on. Facebook and Twitter and Instagram didn't arise until we had the internet in place, and once we get the industrial internet in place, then we'll see all sorts of innovation at the application level. But to feed those new apps, those innovative applications, we have to make the data available to them. So that's what we're focused on right now is data access and data sharing. Okay?
Yeah, excellent information there. So we've talked a little bit, IT, OT, CT. Which job titles are involved with making these decisions to sign off on some of these purchases? Kevin, would you like to take that question?
Sure. It can be, in different organizations, the IT, OT buying centers can have different functions. But if we take a look at the OT side of the house, it's more production, operations, VP of operations, VP of production, supply chain, VP of supply chain, director functions. They can either have influencer or buyer functionality, again, depending upon the maturity of where those BUs are in terms of implementing some of the IoT use cases and value propositions. And then on the IT side, it's fairly familiar to CIO. System integrators also come into play a lot of times on the IT side of the house, where we're using companies like Dimension Data and larger IT houses that are familiar when we were building out our data centers and such. But being able to identify those buying centers and through the culture of the company, it does vary depending on, and then identifying who's the influencer and the decision maker. Again, it's specific to the company, but those are some of the responsibilities within those buying centers.
Excellent. So obviously people want to know what sort of ROI or what sort of payback typically comes with these solutions. Steve, can you provide them with some insights into that area?
Yeah, so I said earlier that most companies, whether they're end users, manufacturers, or they're OEMs, equipment vendors, pretty much get it now that this is, I think, an inevitable trend for them, but they still need to justify investments case by case. You know, even if the grand vision is a data-centric digital enterprise from you know, supply chain to post-sale customer service, then you know it isn't. We're not yet at the point where organizations are committing tens of millions of dollars to do this just for the theory. You still have to justify the ROI of each installation within the context of the broader strategic plan. So, you know, looking at the business benefits of the industrial IoT, I mentioned earlier, operational excellence is one area of focus. Improving customer service is another, and then sort of a third one, a byproduct of the first two often, is environmental in terms of waste and energy consumption and environmental pollution management and so on. So looking at those in terms of the ROI, so operational excellence, right, well, eliminating downtime. You just imagine what downtime costs an automotive manufacturer, costs a logistics company like FedEx, costs a ship operator. You know, the downtime is, you know, it's millions of dollars an hour in some cases, and you know, something as simple as a bearing on a conveyor can create that problem for somebody like FedEx, or a low-cost component on a ship can shut down the power generation in that area. So, you know, operational excellence, the ROI is relatively easy to justify in terms of avoiding downtime. Another aspect of that is spare parts. You know, I'm based in Houston, so I meet and talk with a lot of oil and gas people, and you wouldn't believe the amount of spare parts and equipment that they take to site for drilling. You know, they have 2 or 3 complete sets of drilling equipment on site to mean they have immediate access to spare parts to avoid downtime on drilling, which costs tens of thousands of dollars per hour. So, you know, having no predictive analytics in terms of equipment failure on site can be, you know, the ROI becomes pretty obvious pretty quickly. When you talk about OEMs and customer service, you know, providing customers with superior, faster, more appropriate post-sales support, eliminating, in a sense, still helping operational excellence, but also providing customers data that they can exploit with their own customers is very important. So there's a wide range of tactical ROIs and time to value calculations available to support this. So we don't really see that as a big problem. The problem is getting the solution together quickly and deployed quickly and generating value quickly, because if you've got huge gaps in your solution, you're just providing a jigsaw puzzle of technology pieces, then the customer just turns around and says, well, who's going to put this all together for me? How long is it going to take? What's the risk? And so on. So pre-integrated packaged solutions that are configurable and deployable quickly is the way to justify those ROIs even more strongly. Okay?
Yeah. And Steve, I would just add to that, you know, one of the things, you know, a lot of marketing verbiage it goes around end-to-end architecture, but you really have to look at this as an end-to-end architecture. You can't just stitch product solutions together or products together. You have to have an holistic viewpoint of how you're going to architect from the edge to the cloud, and then identify the hardware and software resources to piece in those puzzle pieces together. But it's extremely important to have that holistic view and not that kind of myopic and siloed product type view. And that's one of the areas where the solution that ADLINK and Intel is producing is truly an application-ready end-to-end architecture that you can plug in.
Yeah, if your tactical solution just creates another silo, you're no better off. You know, you're just doing what we've been able to do for the last 20 years. But it's openness, it's data connectivity, it's end-to-end thinking, cloud to fog to gateway to device. So I fully agree with Kevin there. It's a tactical solution, but in the context of a strategic plan.
Okay, great. So what would be a few best practices for removing some of those technical barriers to connect factories more efficiently? Maybe, Steve, we can have you start with that question.
Whoa, that's a good one, right? Best practices for removing current technical barriers. Well, I think the one best practice is to realize that getting productive consensus between OT, IT, and CT people is not going to come by accident. You know, it's not a natural marriage of technologies or skill sets or operational experience. So I think taking a strategic view, looking at the architecture end-to-end, and creating teams of experts with the relevant experience, whether it's in cloud services or corporate IT or OT, or even the CT world, if data comms is a big part of the solution. You know, getting those teams together to think about the holistic problem and how to evolve the organizational structure and your vendor ecosystem in the right direction for the business is crucial. So best practice, I would say, is think tactically, but also think about strategically as well, and get people working together. Now, I had an interesting conversation with an analyst not so long ago about how the role of the CIO will change in this brave new world of end-to-end connectivity, and I thought his comment was very appropriate. He said, well, 5 years from now, the CIO's office is still going to be responsible for the corporate IT environment, but it will be mainly filled with OT people. And I thought that was quite a neat way of explaining how the OT computing environment is going to be considered all the way up to the boardroom, whereas it might have in the past been considered more of a sort of a island of automation within the corporate enterprise. So cross-team or teams that cross domains and cross skill sets and have this strategic vision and architectural vision, I think is going to be one key best practice in this area.
Okay, great. It looks like we're coming to the top of the hour. I would like to thank everyone for attending today. I'd also like to thank our panelists, Steve Jennis of ADLINK and Kevin Davenport from Intel, for sharing their expertise and insights. For more information on this topic and others, please visit the website reuters.com/adlink-intel/industrial. Thanks for taking the time, and have a great day.
Ladies and gentlemen, that concludes today's conference. Thank you for joining. You may now disconnect. Have a great day.